Hello, Dr. So Mitchum here. Today we're covering the backbone of all research, data. What kinds of information do we collect? How do we describe it? And how do we make sure our numbers mean something useful? Whether you're reading a study or collecting classroom data, understanding variables and measurement is essential. Imagine you're trying to figure out if a new teaching method is effective or if your students are improving in their reading skills. The answers lie in how we handle data. Let's start with variables. A variable is any characteristic or factor that can vary. For example, the number of students in your class, the amount of time it takes students to complete a math test, or the types of reading strategies used. Variables are the building blocks of research, and understanding them is crucial. Now, let's break down variables by their measurement levels. Nominal variables are categories without any order. Think gender, eye color, or the name of a school. You can count them, but you cannot rank them. For instance, if you are categorizing students by their favorite ice cream flavors, chocolate, vanilla, strawberry, you can count how many students prefer each flavor, but you cannot say one flavor is better than another. Ordinal variables involve order, but the distances between levels are not necessarily equal. For example, letter grades such as A, B, and C, or a Likert scale strongly agree to strongly disagree. If you're ranking students based on their performance in a spelling bee, first place, second place, third place, you know the order, but the difference between first and second place might not be the same as between second and third. Interval variables have equal spacing between values, but no true zero. Temperature in Celsius is a good example. 20 degrees isn't twice as hot as 10, but the difference between 20 and 10 is the same as between 10 and 0. Another example is the time of day. The difference between 2 p.m. and 3 p.m. is the same as between 3 p.m. and 4 p.m. But there's no true zero time. Ratio variables are like interval variables, but with a meaningful zero. Think age, height, or income. If someone earns $60,000, they make twice as much as someone earning $30,000. Another example is weight. If one object weighs 10 pounds and another weighs 20 pounds, the second object is twice as heavy. Discrete variables are countable, like the number of siblings a student has. You can count them in whole numbers, one sibling, two siblings, three siblings. Continuous variables can take any value in a range, like height. A student's height could be 5'2" and 5'4", or anywhere in between. And don't forget constants, characteristics that don't vary. Like the number of minutes in an hour, constants are fixed values that remain the same throughout your study. We often cannot study an entire population, so we use sampling. Sampling is like taking a small bite of a dish to decide if you want to eat the whole thing. Let's go over the major types. Simple random sampling means everyone in the population has an equal chance of being selected. For example, using a random number generator to select 50 students from a school, it's like drawing names out of a hat. Everyone has an equal chance of being picked. Stratified random sampling involves dividing the population into subgroups and then randomly drawing samples from each group. Say you want to make sure your sample has equal numbers of male and female teachers. You would divide the teachers into male and female groups and then randomly select from each group. It's like making sure you have equal scoops of chocolate and vanilla ice cream. Cluster sampling means you randomly select entire groups. For instance, randomly selecting 5 schools and surveying all teachers within them. It's like choosing entire neighborhoods to survey rather than individual houses. Systematic sampling involves selecting every nth individual, like every 5th name on a class list. If you have a list of students and you pick every 5th one, that's systematic sampling. It's like picking every 5th apple from a basket. Convenience sampling uses whoever is available, like surveying your own students. It's easy but limits generalizability. If you only survey students in your class, the results might not apply to students in other classes. It's like tasting the soup you made and assuming everyone will like it. Sampling matters because it affects how well your findings apply to the broader population. Random methods are best for representativeness. If your sample is representative, you can generalize your findings to the larger population. Once we have data, we need to make sense of it. That's where descriptive statistics come in. Descriptive statistics help us summarize and describe the main features of a data set. The mean is the average score. If you add up all the test scores and divide by the number of students, you get the mean. It's like finding the average temperature for a week. The median is the middle score. If you line up all the test scores from lowest to highest, the median is the score in the middle. It's like finding the middle point in a line of people. The mode is the most common score. If most students scored 85 on a test, 85 is the mode. It's like finding the most popular ice cream flavor. The range is the gap between the highest and lowest values. If the highest test score is 100 and the lowest is 60, the range is 40. It's like measuring the distance between the tallest and shortest person in a group. We can visualize data with bar graphs for categories, like favorite subjects. If you want to show how many students prefer math, science, or history, a bar graph is useful. Histograms are for numeric variables, like test scores. If you want to show the distribution of scores, a histogram is helpful. Scatter plots show relationships, like hours studied versus grades. If you want to see if studying more hours leads to higher grades, a scatter plot can illustrate that. Also important is understanding the difference between statistics and parameters. If you're working with a sample, you're using statistics. If you're working with the entire population, you're using parameters. Statistics help us make inferences about the population based on the sample. When we want to go beyond just describing data, say comparing 2 groups or predicting outcomes, we use inferential statistics. A t-test is one example. Imagine comparing average test scores between students who used flashcards and those who didn't. That's inference. Another example is using regression analysis to predict students' future performance based on their current grades. Understanding data types, measurement, and sampling strategies equips you to be a critical researcher and practitioner. Whether you're looking at published research or collecting classroom data, these concepts help you interpret what's really going on. Next time you encounter a statistic or graph, don't just skim it. Now you know what questions to ask. Are the variables measured correctly? Is the sample representative? Are the conclusions valid? Thanks for tuning in, and see you next time.